Today's lesson is chapter 8, and we're doing a couple of sections at least, and then we'll also be doing some, we're looking at some of the homework because there was definitely some questions and I see why. And so the first section is 8.1, and they call it perimeter. And then they also are talking about circumference. Okay. These two go together because they're all about measuring the outside of something. So just to have a silly little example, if you had, uh-oh, let's see if I can figure out how to unfreeze that. Okay, I'm coming back. Okay, so if you had a rectangle, what you're trying to do with perimeter is to measure the outside edge. So for instance, if you needed to put a fence around something, in a room, if you had to um, uh, put baseboard around the edge, you would want to know the perimeter. And so it doesn't matter what the shape is. Perimeter is a measurement around the edge, and all perimeter numbers will be like in feet or in yards or in inches or even meters, whatever is listed. That's how it'll be, that many feet, that many yards, or so on. Circumference is all about a circle. And so their circumference is literally the distance around the edge. So again, it'll be the same units. It'll be in feet or yards. So one person, this was in Maine, they had to put a fence around a lighthouse. And so they literally needed to get a measurement of their circumference. And so what they knew, and of course this lighthouse was on an island. So they didn't want to go to the lighthouse, come back, measure it, go back. They wanted to do it in one trip. But what they did know was the diameter of the lighthouse. And so they literally sent me an email and said, how much fence do we need? Because they frankly didn't want to get in their silly little boat and have to go twice. And so I did the computation and I said, just be sure and bring a little extra, just in case. But they wanted to be sure, and it was really a big, it was on the edge of a river that led to the Atlantic. And so you have to worry about tides coming in and going out. And so it was a big deal going out there. But they were still going to do it. They just wanted to do it right. And so that was the fence going around the lighthouse, which was round. So what we need to do is, okay, we need to start looking at various shapes. And so this is all about perimeter. So I'm going to start with a square. And honestly, if you can draw the picture, you could almost figure out the right formula of what needs to be done. With this square, if this one was 5 inches, and somebody said it's a square or it looks like a square, you know what's going on here. The definition of square is that all the sides are the same, and the angles between one side and the other are 90 degrees. And in geometry, they use this little mark here to say it's 90 degrees. Another way to say it, it's perpendicular. So if this was the floor, this would be, vertical. And so that's a square. And so you can just say, well, the perimeter is 5, 5, 5, 5, which is 20, or they give you a formula. It's 4 times the length of one side, S for side. Do you need a formula? Not really. I mean, look at it. And so the perimeter would be 4 times 5 inches, right? Or just add up 4, 5, 5, 5, 5. And so the perimeter is 20, and the unit, if since I called it inches on all of them, it would be 20 inches. And so we want to start putting in the correct unit. And because it's perimeter, it will not have square or anything like that on it. It will be just plain. And so the next shape was a rectangle. And a rectangle is just a square with the two sides, sides next to each other different. And so typically, but it also has the same quality of having a right angle. I don't know if I drew it very well. So if this was 10 feet, then rectangles have opposite sides the same exact size amount. So once you have one, you have two. And let's say this is 4 feet, and this is 4 feet. Now, why did I make them all feet for my example? It's because when I start to add, I need to be adding like things. And I don't know if you remember from the very, very beginning, I said, the assumption is when you add, and I said it in terms of fractions, but when you add, the assumption is you're adding like things. So I'm not going to add 10 feet to 4 miles to 2 inches. You know what I'm saying? I want them all to be the same. And so that's what needs to happen. If you ever run into an example where they're not all the same unit, you need to make them all the same so that you can add them. So there's 2 10s and there's 2 4s. And so the formula, 2 times the length and 2 times the width. Now, again, do you need this formula? No, but the formula basically describes what's in the picture. There's 2 of these ones that are 10 feet, and there's 2 of these sides that are 4 feet. Okay? And so order of operation takes effect here. You multiply ever before you add. So 2 times 10 feet would be 20 feet. And 2 times 4 feet would be 8 feet. And so finally the perimeter is 28 feet. Now, did you have to do it with a formula? Not in my opinion, because all you had to do was march around the edge and add them up. Is that okay? But notice how the unit is the plain unit. It's feet for the example I just gave. And so there's all kinds of variations of different things. This is an interesting one. So what I'm going to have to do is like this. Okay. Well, my drawing is not that great, but this is called a parallelogram. Okay. The feature of a parallelogram is you no longer have the right angle, the 90-degree angle, the angle right here. And so what it's almost like the rectangle got tipped, but what you have, the 2 opposite sides will be the same measurement. So if you took this and tipped it, can you see it? Just pretend it's made up of little segments and it'll tip. The 10 and the 10 would stay the same. So if this was 10 feet, then if it's a parallelogram, this would be 10 feet. Now I'm going to change the numbers. If this was 6 feet, then this would be 6 feet. Now that's what you get when you have a parallelogram. It's a rectangle that got tipped. And so it gets its name because the opposite sides are parallel. So that's like railroad tracks. They're equal distance apart every place. And so this is a mark they use in geometry to indicate parallel. You don't have to know that, but this is parallel to that. And at the same time, this one, the one on the left vertical, is parallel to this. And so that's the name parallelogram. But what happens is you have 2 of the 10s and you have 2 of the 6s. So the truth is we have 20 feet and we have 6 times 2 is 12 feet. So we would have 32 feet on this one, right? So it's the same formula. 2 of the, you know, the horizontal ones and 2 of the vertical ones. And so that's how we would get the perimeter. Now, there's one more. And the one more is a triangle. And I'm going to start with this shape. And I did this before, and I've actually made it like 90 degrees. So it's kind of like a rectangle. In fact, I want you to see visually that the triangle is really half of the rectangle. And in some ways we'll be looking at that, but I wanted you to see it visually. So what they will use, the tendency is to call the bottom one B for base. And this one here, H for height. Now the height, the measurement of the height has to be perpendicular to the base. So it's if that there is this big cardboard box that you were trying to push through a door, and you're really interested in how high it is so that it'll fit under the door. I don't know if that's working for you. But what you would do here is if you had to do the perimeter, you would have to add this one and this one, and finally this last one. So you would have to add 3 sides. So let's say this was 5 and this was 12 and this one was 13. And let's make them all meters just to show we can. Meters, right? And so the perimeter would be 5 meters and 12 meters and 13 meters. The picture showed us what to do. We didn't need a formula. We just marched around the outside. And so this is 26 and 5. I'm getting 31. Tell me if you don't like it. Or is it 30? Which is it?
It's 30.
Ha, thank you.
Yeah, I know.
This is a wake up call, right? So there it is. Yeah, I did it this way and then I did it the other way and I realized I didn't do it right. So how do you like that? So do you see the picture really tells you what's going on? And so that should work. And so now we're into the circle. So there's a center and there's a measurement from the center out, which is called the radius. Okay. And then if you measured all the way across, the whole thing would be called the diameter. And when we do the formula, sometimes it's easy to use the diameter and sometimes it's easy to use the radius, because the radius is just basically from the center out. And so we need to be able to go back and forth very nicely. So let's say the diameter was 16 inches from here to here. It would be the same regardless of where you measured it, but I just did it horizontally, then the radius would have to be half of that. And it has to be exactly half, because if it's not exactly, it wouldn't be a perfectly good circle. Because when you make this, you rotate around the center. And so it's got to be the same everywhere, 8 inches, and then the other side would be 8 inches. So we need to be able to do that. So we kind of look to see which one do we have and what's the deal about it. Now, I want to do circumference, and I'm going to make it a little bit bigger. So if for some reason you had the diameter, and let's say the diameter, I'm going to use D, is 10. The question is, what is the circumference? So straight across is 10, going through the center. What is the distance? And I'm going to start right there. What's the distance around? So it's interesting because sometimes the history, let me see if I can pull this out. I use what I have. So this is, I don't know, this is a charger for something. So the Egyptians, it's so interesting, they thought it was going to be 3 times. So they thought it was going to be around 30. If the diameter was 10, they thought it was going to be around 30. And so that was one of the earliest guesses about what's the correct answer. But this is what I'm going to do. I'm going to take this thing and I'm going to mark it off. Do you see where my hand is? So I'm going to go from there to there. Okay. Now, why am I picking something like this? Is because I can bend it. So I'm going to start here and I'm going to measure around, and my first mark is there. Let's see if I can mark it. Around there. Let me double check. So you see what I'm doing? I'm measuring. Okay, so the first mark would be about where my mark is. The second mark would be right around there. You see what I'm doing? And my third mark I want you to see this visually. The 10, this was the first 10, this was the second 10, this was the third 10, but it wasn't exactly 3 times, was it? Even with my stupid measurer. I used to use my purse to do this in class. There's a little bit more. And that strange little bit more is part of the formula. Circumference equals, does anybody know what it is?
3.14.
That's exactly right. 3.14 multiplied by the diameter. Now, this number comes up in mathematics a lot. I cannot believe it. And it's not exactly 3.14. It's one of those numbers that goes out on and on and on, out to infinity. It never repeats itself. It's like its own number. And so it goes on and on and on. And so if we use this as a pretty good approximation for the number of times it went around, it would be 3.14 multiplied by 10. You see why I picked 10. Because when you multiply by 10, it's a decimal shift and it's 1 to the right because multiplying makes it larger, right? So the answer would be 31.4. And if this was yards, this would be yards. Okay.
Question.
Yes.
How did you get the 1, 4?
This part, well, they kept measuring it and measuring it. This goes back. The Egyptians were very interested in geometry, and And so they were trying to figure it out. I mean, other civilizations tried to figure things out, but it was interesting about the stories I heard about the Egyptians trying to figure this out. But they just kept measuring and measuring, and all of a sudden they said, oh no, it's a little bit more than 3. So I'm trying to give you something to remind you about. It's a little bit more than 3. And
Is it always 1, 4?
yes,
Okay.
this is what I remember. 3.14159, and it keeps going. And one time at our school, we had, you probably heard of Pi Day.
Mhm.
Have you? Pi Day. So it's March 14th. So that's 3/14. And so they would do all kinds of crazy things to do with pie, you know, whatever you can think of. We made T-shirts. We made pies. Encourage people to play around with the, you know, but this is Pi Day, and it's an official thing. You can look it up on the internet. March 14th, every year, somebody's talking about Pi Day. And one person made their T-shirt, and this, of course, you could go out for 100 decimal places and it would never repeat itself. It's a fascinating number. So if you're going to talk to some alien being, this is sort of like a Star Trek thing. Sometimes they would send out, you know, many, many decimal places of pi and see if they're intelligent, they're dealing with, because this is a universal constant. It's something that comes up every time in many, many places. And so if another civilization or whatever, if they dealt with mathematics, they would have come up with this number themselves. That's what I'm saying. So I don't know if you want to be Star Trek people, but that's the idea. So how's that? So can you see it? 1, 2, 3, and a little left over. And when they figured it out, they found this number. You can see that rounding to 3.14 was a pretty good idea. In most cases, it's close enough for what we need to do. So does that work for you? So the thing that might happen, of course, is they could give you a circle and they could say, well, the radius is 3. Okay. So the formula I gave you, circumference equals pi multiplied by d. And this pi, this is the Greek letter pi, because the Greeks had a lot to do with mathematics as well. And so we use this symbol, you know, sometimes it kind of comes up like that, but the formula would be, if we're using 3.14, and then we would have to multiply by the diameter. Now, what is this, the diameter?
No,
No. So what would be the diameter?
2 times the radius.
Yes. So we would have to fix this up and say, well, the diameter is 6, and then we would put 6 in here, and we would do it. And, you know, if you want to use a calculator, I couldn't really care. 18.84 inches. And I have no idea, 24 carry 2, 8, 18. I like it. So that would be the formula. Now there's another version of this formula. I kind of like this because of the, you know, moving the thing around. But the other version of the formula is this, 2 pi r. So with my same exact formula, we had r was 3 inches. I think it was 3 inches. So it would be 2 times 3.14 times 3 inches. Well, if you stare at this a little bit, you can see that these all have to be multiplied together so that the 2 times 3 will give you 6. And 6 times 3.14 will give you the same answer we just had. So this is the formula if you just don't want to convert the measurement of radius to diameter. And so this would be fine. But in the end, it's going to be the very, very same number as we had before. So in my mind, here's one formula. Here's the other formula. And they're both perfectly good. So if you learn 2 pi r, maybe you want to stick with that. I don't care. If you don't, and you like this one because it looks a little bit simpler, you just have to make sure that you're putting the diameter in there when you work the formula. So it doesn't really matter. These two are equivalent. Can you see it? So it doesn't matter one little bit.
I have another question.
Go for it.
Okay, so you have it written on the bottom, C equals 2 parentheses, blah, blah, blah. How do you know not to multiply them across? All of them.
You mean this times that in that
Yeah.
order? Huh, that was at the very beginning of the course. It had to do
I remember.
commutative. Remember commutative
Yeah,
and associative, that kind of thing.
yeah.
I just personally like the 2 times 3 because I could do that in my head. And then I multiplied that by that, but you didn't have to. I wanted to show you that it was equivalent formula. And so remember, commutative meant you could take 2 numbers added or multiplied and switch them without affecting the answer. And so in a way, that's what I did. I took my 2, I then took my 3, then I took my 3.14. I switched those two. I'm allowed, commutative, right? It's not going to change the answer. Now you can do it. 2 times this would be 6.28 times 3. That would get you there. So I just sometimes see, something that appeals to me more and do it that way. But I know that I'm allowed to because there's a rule that says it's okay. You can do it if you want to. Did that satisfy the answer?
Still confusing though.
Yeah. Me
That's
too.
the S2.
Did you want to just do it straight from left to right? Is that what you want to do?
You multiply 2 times 3.14 times 3 inches.
Yeah. I mean,
Oh,
it doesn't matter.
as you said,
numbers.
add.
They all have to be multiplied. The order that you multiply them does not matter. That's what
Well,
I'm
I
trying to
understand that. It's just, how do you know? I thought you said to add.
say. No, I was trying to talk about the commutative property, which also works for addition.
Oh, okay.
Maybe I shouldn't have brought that in. But the commutative property of multiplication says you can multiply your numbers in any order. In other words, 2 times 3 is the same as 3 times 2.
Right. Okay. Now I
That's
got
all I was saying.
it. Okay.
Are there more questions before we go on? I want to clear this up.
No, all good.
You good? Okay. All righty. So that's basically those are the formulas. But my thing is, I would say draw the crazy picture and label the parts and go from there. I think that's your smartest move. And honestly, when I see somebody has drawn a picture and they couldn't go any further, chances are I give credit because I like pictures. Because the minute you see, there's a step to get from a problem to a solution. And so the picture is the first step. You're trying to visualize what you're dealing with. And so that's step one, and then you keep going from there. And so the picture's worth something in my mind. Okay. Now, the next part, what I want to do, I think I'll do 8.2 next. 8.2 is all about area. Let me bring this so you can see it. And so back to all the pictures that I did. I think this is going to all fit together beautifully, and it's a visual thing. And strangely enough, geometry is on the other side of the brain than algebra. Okay, so you know,
Wait,
some people are better on one side of the brain than the other. Well, this is more on the other side of the brain than algebra, and sometimes this appeals to people more. But here's the square.
wait, teacher, before we move on, can we do a couple examples on the last one?
What I was going to do that later.
Okay.
As long as you know, yeah, we're going to do them because I know there's some problems in the homework.
Definitely.
Definitely. Okay, so let's just get the area formulas out of the way. This side here, let's say it's 4 feet, is the same all the way around. And so what you do is the area would be the 4 feet multiplied by the 4 feet. In other words, it's roughly the length times the width. Now they may say side squared, but it's really because the two sides, all the sides are equal, you need the length and you need the width. And so 4 times 4 is 16, and feet times feet is square feet. That's one way to say it, or like that, square feet. Here's your lovely rectangle. It's really the same formula. Here's the length, here's the width. This one's 8 feet. This one's 3 feet. Area is the length times the width. 8 feet multiplied by 3 feet. Area is 24. What?
Feet.
What
Square
kind of
feet.
square feet? Do you like either one of these better?
I like the bottom one.
I do too. I think it's quicker to,
Yeah.
although you'd say it the same, square feet, square feet. So all area turns out to be square something or others. So if it's feet, it's square feet. If it's inches, it's square inches, and so on. So these two are really the same formula, aren't they? And I'm going to try to do the parallelogram. Okay. It's kind of like the rectangle that got tipped. What I want you to do is, see this triangle on the very left? I'm going to put it, I'm going to move it. I'm going to take this triangle, take it away and put it over here. So this gone, and I'm going to put it here. And tell me what I have.
A square.
You have, yeah, you have a rectangle. And so the formula, see if you can see it visually, you don't have to memorize all these crazy things. This bottom number was the base, and this was the height. And so it's really like this measurement, which was the length, and this measurement, the width. And so the area is equal to base multiplied by the height. They're using different letters for this, base and height, but it amounts to length and width, but it has to be vertical. This has to be a vertical measurement. And so there you are. One more same formula. So they might try to trick you.
On the parallelogram, does that mean that the answer is squared as well?
It's going to be squared. All area is squared.
Oh, just want to make sure.
Oh, yes. And so I'm going to give you some triangles. This is visual. Area equals the base times the height, and it's 1/2. Visually, it's 1/2. And exactly, it's 1/2. Now, if they draw it differently, like that, then this is the base, and the height is this dotted line. So that this measurement on the left and this on the right do not come into play when you're doing area, because the area is 1/2 times the base number times the height, and they've got to give it to you. So just look for that measurement, the one that's vertical. And then it will be square units, because this will have, let's say it's feet, this will have feet, this will have feet. 2 feet make square feet, right? That's not good English, but there you are. How is that? And I think I'm going to save the, let's see, maybe I'll just do it. How on earth are we going to do the area inside a circle? Good question. So at the Science Museum in Boston, the big one, they had a beautiful demonstration of this particular formula. And what they had was a circle with sand in it. And they had a way to say, you're only interested in the circle, inside the circle. And so the question is, how many of these squares could you fill? I'm going to go at this again. If I took everything inside the circle and used some of it to fill in these corners, how many full squares would I have? And so what I'm going to do is visually take a little piece of this from this section and put it over here. So I have 1 full square. And I think I have enough left over to fill in this little corner. So I'm going to take in a bit and I'm going to remove it and put it over here. Can you see that I would probably have enough sand to fill in 2 full squares? What about this third corner? Do you think I have enough left to fill it in? I do. I'm going to fill it in. In fact, I have 1 full square, 2 squares, 3 squares, and a little bit left over. It's that same number we found before. How many squares? So we have area equals how many of these, and this was a radius, and this was a radius, and this represented a radius squared. And how many would we have if we moved stuff over to fill it in? We would have 1 of them, we would have 2 of them, we would have 3 of them, and a little bit left over.
Is this that 3.14 thing again?
Exactly. So it came up again.
Again.
It comes up with circles, and it's, I love this thing because they had so many visual looks at mathematical formulas, but I hope I did it well enough for you to see that if I move something from here to fill that in and filled in the other, I would have 3 full radius squares, R squareds.
Why
But
did you put,
there was some left over, and that's where the formula comes in.
why
3
is it R equals R to the second power? I don't
Those
understand.
are square radius. This is, if I had, this is R and this is R times R is R squared. So it will be numbers. So if this was 3, this was 3, this would be 3 times 3.
Oh, okay.
So this is a square radius, not, the formula is a square radius. The visual is a square radius. It's a square. It's a square. So we turned a circle into a square. But there you are. This is whatever the radius measurement is squared. So if it was 3, it's 3 times 3. If it's 5, it's 5 times 5.
So why couldn't you make a square out of the last one?
There wasn't enough left over. See, we would move most of it away to fill in the corners.
Okay, okay.
And there was left over, and so it wasn't exactly 3 like they originally thought. It was 3.14. And when they figured it out perfectly, this is what they came up with. Area equals pi r squared. Pi times radius squared. And
Area.
so I don't know if this demonstration worked for you, but there is your formula. So if somebody said, I'm going to make it easy, the radius was 5 feet, you would do the following. Pi, they're having you use 3.14. The radius would be 5 feet, and it's squared. So it's basically 5 by 5.
So do you always use 3 point
Yes, it's always 3.14,
going
regardless of
around?
the size of the radius. This is always the number.
Okay.
And, you know, if you needed it to more decimal places, you would look it up, find out there's more decimal places. But this is for most practical things, this is good enough. And so the order of operation kicks in. 5 times 5 is
25.
25, and it is square feet, right? Because it would 5 feet times 5 feet. 5 times 5 is 25 feet times feet is square feet. And then you would multiply that by that. And I think it's, I don't know what it is, 78 point something. 3.14 times 25. 78.5. Okay, I use the calculator. Although I used this example before, so I knew it was 78 something. How's that?
Good.
Okay. So I think that will do us. I mean, that's, those are the basic formulas, and I wanted to see how they would look visually. I like the visual approach. I think I told this story. Did I tell this? I had a neighbor that needed help in algebra, and I taught it to her from a visual point of view because she was an artist. And so I worked on the side of the brain that worked for her.
Huh.
And it's possible to switch back and forth from different sides to go with your strengths. But here were some of the problems. This was somebody, so this is the homework. Can you see it? Everybody see it?
No.
Oh, it didn't work? Let me go back. See, share, that one. Let's go there. Let me try again. I know how to try again, don't you? Okay. Here it is. Can you see it?
Yes.
Okay. Somebody asked me about number 2. Now, they may have had a different set of numbers, but this was in a message. And if you want a different problem, let me know. But notice this is a rectangle. And so if you need the perimeter, the answer will be in yards because both of them were in yards. So I would have 2 4s. And so if you would just write, on your paper somewhere, I would have 2 4s, 4 times 2, I would have 8, right? And 2 of these 3.5, 3.5 doubled is 7, right? 3.5 and 3.5 is 7. And so 8 and 7 would be 15 yards.
Oh,
Do you need to see it visually, or can you from the formula? So I would have a yard on the left and a 4 yards on the left and 4 on the right. I would have 3.5 on the bottom and 3.5 on the top. And I added them all up. Does somebody have a different one?
Yes, actually in the homework for number 2,
Yeah, go
I'll be
ahead.
able to, that was what had different answers in different places.
Okay,
So
so
not,
can
not
you
in,
tell
well,
me
I'm
what
sorry.
the problem was, or do you want me to go to your homework?
In the coursework, yeah. Not in the testing area, I guess, but
Oh, that's right. Was it, it was in the reading.
yes.
Okay. So let me see if I can go back to the reading. So it was, well, like the ebook.
I hope ebook is the same. Yes, ebook.
Yeah, let's see. And maybe they messed up.
Yeah,
This
that
is
was really.
not it. This is you didn't want this, did you? Or did you?
No, well, I don't see anything there.
Okay, let's do this one.
Let me see if I have it.
Yeah. We need to see the actual problem. I don't know, that's not doing it
Yeah.
either.
Let's see here.
Let's see, ebook, maybe it's this. And we want chapter 8.
Yes.
I'm gonna, you know what I'm gonna do?
page 425.
Yeah, I need to figure out how to get there.
Right there.
That will do it. It'll take me forever to get there.
Actually,
Put
if you
in
go to the,
put in the pages 425.
Can you fill it in the,
Oh, thank you so much. See, you guys are smarter than me. 425.
oh,
actually go to the contents, that'll take you right there.
Contents.
Yeah, well, yeah.
Right there.
Oh,
There you go.
okay. So we need to get in chapter 8.
that was easier.
Oh, thank you. All right.
You're hired.
Making me log in. Oh, like I'm a suspicious person. Okay, so tell me how far. So this is what I was looking at.
Yeah, this one, number 2, yeah, 2B.
A B.
Yes.
Okay, so this is a triangle,
Mhm.
right? And so the base is the bottom. Usually that's the bottom. Oh, no wonder. Oh my gosh. It did make this hard. Okay.
Well, the issue is not so much that it's hard, is that there's 3 different answers from the book, from the teacher, and from me.
Okay. Well, let's find out who's right.
Yeah.
So the other 2 sides are 1 7/8.
Yes.
All righty. I'm going to have to show you paper, to be honest. So let me just do that. Oh. And I see a chat, but I'll get to it in a minute. So this is what I saw. And what did they want? Did they want the perimeter?
Yes, they want it in inches, yes.
Yeah, they want the
Perimeter.
perimeter around it.
Okay,
The
so,
nearest tenth.
okay, so what I'm gonna do, the perimeter, so, once it's perimeter, we know just go around the edge. And so, I'm gonna just go 1 7/8, 1 7/8, and 2 5/8. Okay?
Yes.
That's all that needs to happen. I was afraid we had to do area. And so they all have a common denominator, which is fortunate. So 7 7 is 14, 14 and 5. 14 and 5?
Yeah.
19/8, and 2, 3, and 4. Now, this is not considered good form because this is improper and so on. So what I need to do is sort this out. 8 into 19 goes twice. 16, right? And 3 left over.
Yes.
So it's 2 3/8, and that's 4. And literally it's 6 and 3.
Oh, 3/8.
Now, if they wanted it as a decimal, is that what they did?
No. It's,
So this is the correct answer.
oh, yeah, as a decimal.
Okay, and so now they're relying on the fact whether you can remember how to take, this was the last chapter, take the 3/8 and turn it into a decimal. So 3/8, sorry, is 3 divided by 8. And so this is what you need to do. Add 2 zeros or something, bring this up. So 8 into 30 goes 3 times. 3 times 8, 24. 6 left over. We ran out of room. I know how to fix this. 8 into 60 goes
7.
7. 56. 4 subtracting. I'm going to add 1 more 0 because that will make it perfect. 8 into 40 goes 5. This is now an exact answer. So 3/8 is now 0.375. And so our answer was 6. There we go. Our answer was 6 3/8. So that would be 6 and
0.375.
375. Now,
Round-
they
round
want
it to
to
the
round the stupid thing.
That's the part I have trouble
Did
with.
they want to round it or not?
Yes, to the
Yes.
nearest tenth.
Okay, so if it's rounded to the nearest 10th, then this is the last place to see a number. This is the deciding piece. So the 7 makes the 3 go up. So I would say 6.4. Is that the answer that any of you had? Vermont?
Yeah, that's what they wanted. See here.
So did you get the 6 3/8?
But
Oh.
the Map TV had 9 inches for some reason.
9.
Yes.
They had a bad day.
Yeah.
I can't
The
imagine.
book says
I'd like
6.4, but on TV they said 9 inches.
Yeah.
Yeah, I'll look at that. So it's on the TV. They made a
Yes.
mistake and they didn't catch it.
Right.
But
The
this,
students were doing it.
oh, the students did it. Oh, hell. Usually they're pretty sharp, but you know, that's good. Okay.
Okay, thank
So
you.
what else? Are there any more that I can do from the homework? Because I'd go straight over there if I could. Somebody else had asked about doing more problems. Tell me what they need.
So on like the homework number like 11,
Okay, I'm going over there. So let me get us over there. Okay, so we got to get out of this. Thank you for knowing how to make things work.
Mhm.
Better than me. Number 11, was it the next section?
Oh, it was problems 8-1. Oh, is it in the book or the homework?
Well, I could do it from either place, but tell me now.
Okay, hold on. Let me go back to my homework. I'm sorry.
It's okay.
Okay.
Yeah.
Oh, it's number 4.
Okay, let's see what it looks like. This?
Yeah, I just want to be for sure I know how to do it.
Okay.
So I'm thinking
Um,
that you just make the little invisible line over to make it a square.
I don't think that's a good plan.
Okay,
I'm gonna mark it 7, 22, 8, and 20, and it was all in yards.
okay.
Okay. So, and then I'm gonna do this one, then I'm gonna stop the video. So here's what it looked like. And you had almost all of the measurements, but not all of them. So what you don't have is this one, and you don't have this one. You have the others, the 8, the 20, the 22, the 7, those are all good, but you can get them because this was basically squared off like a rectangle. And so if this total amount was 22,
Okay,
this total amount is 22, right? From here to here would also be 22. Now this here, this in the dotted part is 8 because it matches that. So if this would have been 22 total and this is 8, how much is left for this little segment?
12. Oh, 14.
Exactly. Okay, we're going to do the same exact thing this way. If this is 20, then from here to here is also 20. Right? From
Correct.
there to there would be 20, just like on the other side. Now, this much is 7 because it's a match of that. So if the whole thing is 20 and this piece that's not included is 7, what does that make this piece?
13.
Correct. Did you see how I did it?
I did, but I did it.
Yeah, it's a visual thing. I don't think I could explain it any other way than showing you visually. And so when we knew the whole top to bottom was 20, and we knew this piece was 7 because that's 7, then this had to be 13. Now you've got all the pieces, just add them up. You've got every
Okay.
single line. And that's a very good problem. Because, you know, when you're working with things like around the house, things are not just perfect.
Can you go over it one more time?
I know. Thank you, Sophie.
Okay? So I'm going to use color. I'm going to use color. If this and this is 20, because they said so, right?
Right.
Then this down to here will also be
Also.
20.
Oh, will be 20.
Yes, but
What
what
about the-
we want, we don't want all of it. We want this piece of it.
Okay, okay, that's the difference.
So
I
this
saw the
is
22.
So-
but that-
And so what's missing? It's not a full 20 on this right side. The
Right.
7 is a match of this. That's why this piece that we wanted
you're about to fall.
was 13.
Gotcha.
Okay.
So you add,
Yeah, I'm going to stop the recording for now.
okay.
Okay.